In the summer of 1975, a team of researchers from NASA and Stanford University, led by physicist Dr. Gerard O'Neill, envisioned what future space colonies might look like at NASA's Ames Research Center in California. The goal was to design an orbiting community capable of housing 10,000 people using the materials and technologies available in the 1970s, with an emphasis on cost-effectiveness. The idea was to harvest the mineral wealth of asteroids, including cobalt, iron, nickel, and platinum, to support these colonies. To bring this vision to life, artists were commissioned to depict the space colonies, which needed to rotate in order to create artificial gravity. These captivating concepts of space habitats, which sparked the imaginations of many aspiring dreamers, still appear as strikingly beautiful today as they did back then. 3 primary colony designs were imagined: a toroidal, donut-shaped colony, a cylindrical colony, and a Bernal sphere, where inhabitants would reside within the surface of a sphere. Each design was intended to rotate to simulate Earth's gravity, and large mirrors would reflect sunlight into the interiors of the colonies. These self-sustaining habitats were envisioned as places where people could live out their entire lives, with artificial gravity and, in some cases, controllable weather systems to create a comfortable environment. The colonies were designed on a grand scale. Cylinders as large as 5 miles, 8 kilometers wide, and 20 miles, 34 kilometers long, constructed from materials like steel and glass. The researchers also tackled practical challenges, such as radiation protection from cosmic rays, naturalistic sunlight, power generation, pest-free farming, and orbital attitude control without the need for reaction motors. While the goal was to make these habitats as self-sufficient as possible, all of the designs would still rely on regular supply shipments from Earth or the Moon, especially for raw materials and essential resources. The proposals sparked widespread public interest, leading to the formation of the L5 Society in the United States, a group of enthusiasts eager to build and inhabit such colonies. The society was named after the L5 Lagrange point in space, one of the areas considered most suitable for space colonies due to its stability and economic potential. Space colonization was seen as a solution to multiple challenges: security, resources, energy, and the availability of raw materials. Habitats in space could offer protection from Earth-based disasters, such as overpopulation or catastrophic meteorite impacts. While a single habitat might be less secure than Earth, a network of colonies would significantly improve humanity's long-term survivability and provide opportunities for migration. Space is rich with the same raw materials found on Earth, and with vast amounts of energy available, space colonies could become profitable if the infrastructure for space mining and manufacturing were established. Although the initial investment would be substantial, the potential for endless profit and expansion would be far-reaching. With abundant resources available within the solar system and the relatively low cost of transporting materials outside of planetary gravity wells, it's feasible that a large permanent population could live and work in space. Habitats located away from planetary shadows could harness solar power around the clock, and zero gravity would allow for the creation of enormous, lightweight mirrors to concentrate this constant energy source. Additionally, space colonies could use nuclear power, which would avoid many of the environmental and safety concerns associated with nuclear plants on Earth.